Okay, so we're going to do some things with angles today. I know a lot of this is going to be reviewed from like junior high, so bear with me. Okay, here we have the formal definition of an angle, which you're probably never going to use again, but it's formed by two rays that have a common endpoint. And this endpoint is the vertex, and the rays are called legs. And we're going to draw that here. Okay, so I've got my vertex labeled with that big dot. That is the vertex. And then each of these rays are legs. So we got a leg and a leg. And that makes up a whole angle. Okay, now there are several different ways to name angles. The most common way is this first way with the three letters, angle CBA. And be careful, you need to be able to trace the angle in that order, C to B to A. Okay, you can go the other direction and do angle ABC. Again, that's traceable, A to B to C. But you will not find a correct as BAC, because if you trace that way, you don't actually get the angle that you were looking for. So make sure it's traceable. Sometimes you can label it by just the vertex, if that's the only angle B that there is. But if there are multiple angle B's, like if there was another leg up here from the B, now there are more than one angle B, and I'm not sure which one you're talking about. So I'd have to use three letters in this situation. But if it was just like the original, then there was only one possible angle B. Okay, and then sometimes they put a number inside just to identify. So this is angle 3. This is usually only done if there's a whole bunch of angles all stuck together. And they do that to make it easier to label. Now, this is not a degree measure. This is not a 3-degree angle. This is just angle number 3. Now, here's the example of when there's multiple angles coming out of the same spot. Just allows you to name it faster. The cursive M in front of the angle means measure, so we would write it like this, measure of angle ABC, and then that would equal like some degrees, like 60 degrees or 90 degrees. M means measure. Okay, super review. You've got your acute angle, which is less than 90, and your right angle, which is exactly equal to 90. And then there's a little symbol that you can put in a right angle only. You put that little box in there, and it means that it is exactly 90 degrees. No other type of angle can use this symbol. And then we have obtuse angles. Those are greater than 90, but less than 180. And a straight angle is exactly 180. In geometry, we will not have angles that are greater than 180. We're going to stick with anything less. So like that angle, we'll do the smaller side of it so that it becomes less than 180 degrees. Okay, this angle is already lined up on a protractor for you to use. One of the angle legs has to point to a 0. Could be on either side. In this case, it's on the right. And then the vertex has to line up nicely under the center of the protractor. Then you look at the other leg, and it's going to intersect 2 different numbers right there. In this case, it looks to be 135 and 45. So I'm just going to jot those 2 numbers down and then zoom back out. And now I have to decide which one is the correct one. So look at the whole angle. Is it acute or is it obtuse? And pick the number that goes with it. So in this case, it would be 45 because this angle is less than 90. So we choose the number that's less than 90. And we are classifying it as acute. We'll do the same thing here. This time the angle is pointed to the 0 on the left-hand side. So we're going to find the 2 numbers where the leg on the right crosses. Looks to be 133-ish and line 47. And then again, go and look at the whole angle and decide, is it acute or is it obtuse? Since it's obtuse, we need to pick the number that is greater than 90. Okay, try to do this one on your own. I'm going to write this one nicely. Measure of angle XWZ equals 65 degrees. And since it is less than 90 degrees, it is classified as acute. If you ever don't have your stylus, you can type these symbols out. It takes a little bit of time, but it's there. So for those of you who have horrible handwriting, this is an option. Okay, now we're going to draw an angle on a protractor. So always start with the vertex underneath the center line, and I highly suggest you use your line tool here. So I'm going to put my mouse under the center, and I'm going to drag it over to the 0. And then for the other leg, I'm going to do the same thing. I'm going to start at the center, the vertex, and I'm going to drag it, and then I can adjust until it looks like it's right at 15. And then since these are rays, we're going to put some arrows on there and label it with the letters of the angle. Okay, the vertex in this case has to be O, because O is the middle letter in the angle name. And the C and the B, doesn't matter which one you put them on. Okay, let's do it again. This time I want you to point the angle the other direction. So using your line tool, start at the center and go to the left, pointing at 0. And then choose the correct 150 degrees. There's a 150 number that makes an obtuse angle, but there's also 150 that makes an acute angle. But 150 is greater than 90, so this would be obtuse. And then we're labeling here, the H and the R don't matter, but that T is the vertex. Okay, yesterday we did segment addition postulate. Well, angle addition postulate is exactly the same. It's part plus part equals whole, except we're referring to parts of an angle. So this is one part, MLT, angle MLT. And then angle TLK is the other part. And angle KLM is the whole. So when I'm labeling multiple angles, I'll put a big arc that crosses over both of them so I can tell where I want to start and where I want to end. So we're going to use the angle addition postulate to find some missing angles. First thing is you should start labeling what you know. You know that the measure of angle RTD is 39, so I'm going to write 39 in that angle corner. Okay. We know that the angle DTE is 56. And then angle RTE is the whole thing. So I'm going to take those two parts and add them together to get our whole. So measure of angle RTE is 95 degrees. Okay, let's do it again. Label angle LMA. This time we're starting with the whole. Angle GMA is 56. And we're trying to find angle LMG. So we can set it up as part plus part equals whole, 56 in the side we don't know. Or you're probably already doing the subtraction in your head, where you take 164 minus 56. We're going to do it one more time, but this time we have algebra expressions. So we're going to label the angle first. So here's angle SRG. It's nice that I can trace it with Cami and then I can get rid of it. And then I'm going to trace angle GRA. And label it. And then angle SRA is going to be that whole. So then we're going to set up the algebra equation. Part plus part equals whole. So we have 2x plus 1 part plus x minus 3 other part equals 154, which is the whole. And then we're just going to work the algebra out from there. These parentheses don't mean anything algebraically because everything is plus and minus, and we work that left to right anyway. Okay, so we've worked all that out, and we get x equals 52. But in geometry, we don't care what x equals. We want to know the measures of these angles. So I'm going to plug 52 into 2x plus 1, and I'm going to plug it into x minus 3 to find the actual angle measures. Okay, segments had bisectors, but so do angles. The bisector of an angle just cuts the angle right down the middle through the vertex. So not like this. We are going to cut it straight through the vertex, like so. And then now I know these two sides, these two smaller angles that have just been formed, are going to be the same measure, because the original angle was cut into two equal pieces. So we can mark that with a special mark. We learned about tick marks for segments if they had the same length, while angles have the same kind of thing, but they're little arcs. So if the arcs are the same, then the angles are the same. Here we know that AC is a bisector, so I'm going to label those, I'm going to mark those two halves as being the same. And then I'm going to fill in the information I know. I know that angle LAG is 64, and that happens to be the whole angle. So since this is bisected, that's going to get split into two equal pieces. Alright, last one. I've marked that the angle is being bisected, showing that those two sides are the same. I want to find angle PTG and label it with 26 degrees. And then since I know that that side is 26 and the other side is marked as the same, it must also be 26. And then I can figure out my whole, good, which is 52. It's two sets of 26. Alright, sorry for all that delay. Since this was a voiceover, you can't hear anything that's going on in the background. And I'm sure people were asking questions or talking at the time. So, hopefully this is helpful, and I hope to see you back soon.